Hi folks, it's Mrs McInnes here. Welcome to lesson 4 of our Quadratics part 2 topic. So today what we're going to be doing is looking at applying what we have already been learning to some problem solving style questions. So these types of questions are often posed in a sort of real life situation. But it also could be related to another topic in maths. So it could be something involving Pythagoras, could be area, various other things. So to be able to do these questions, we have to actually make sure that we read the question and understand what we're being asked to do and think about if our answers make sense in the context of the question. So the first example we're going to look at today is example 8, where we have a rectangle with sides x plus 7 centimetres and x minus 1 centimetres. And we're being asked to find the value of x, given that the rectangle has an area of 48 centimetres squared. So the first thing to do would be think about what are we being asked to do? Well, we're being asked to find x and we're given the area of this rectangle. We're also given an expression for the length and the breadth. So if we put all that together, really what we're doing is an equation where we have area equals length times breadth for a rectangle, but we're going to put in all these algebraic terms. So our area is 48, our length is x plus 7, and our breadth is x minus 1. We're being asked to solve this for x, and this now looks more like the kinds of questions we were doing previously. So what we need to do is we need to rearrange this equation so that we have all our terms on the left hand side and then equals 0 on the right before we can solve. So let's go ahead and do the rearranging first. So we've got 48 equals. If we break these brackets out with FOIL, we've got x squared plus 7x minus x minus 7. And then if we tidy that up, we've got x squared, 7 minus the 1 leaves you with 6x minus 7. At this point, I'm going to swap the sides around so that my letters are all on the left. So x squared plus 6x minus 7 equals 48. And then the last thing would be to bring that 48 across. So we would subtract 48 from both sides. So minus 7 minus 48 is minus 55 equals 0. This is now ready to factorise and solve. So we're looking for our double brackets because it's a trinomial. We're looking for the numbers that multiply to minus 55 but add up to a positive 6. So for minus 55, we could have 1 and minus 55, minus 1 and 55, and we could also have 5 and minus 11, or minus 5 and positive 11. So to get positive 6, it's going to be minus 5 and positive 11. Minus 5 add 11 gives you 6. So x minus 5, x plus 11. So if we solve here, we've got x minus 5 equals 0. So x would be equal to 5. And our other solution is x plus 11 equals 0. So x equals minus 11. Now, because this question was given to us in a context, we need to think about if our answers make sense as answers. So if we look at the x equals 5, first of all, if our length is x plus 7, that would then be 5 plus 7, so 12. That's fine. And for our breadth, we've got x minus 1. So if we check if that answer makes sense, x minus 1, that would be 5 minus 1, so that would be 4. So we would have a length of 12 and a breadth of 4 centimetres. That seems fine. If we check the other answer, minus 11, for our length x plus 7, that would then be minus 11 plus 7, which is minus 4. For our breadth, if we have x minus 1, if x is minus 11, that's minus 11 minus 1, which is minus 12. We cannot have negative lengths. That does not make sense in the context of the question. So what we would do is we would draw a line through this and we would write beside it disregard. What that means is that you're showing that you have found the solution, but we're not going to include it as our final solution because it doesn't make sense in the context of the question. So x equals 5, a nice bold underline that is our final answer for this question. We were asked to find the value of x, and then if we underline x equals 5, that's us saying that is the answer that we are giving for x. Okay. Another problem-solving style question we have here, example 9. We have a 5-metre ladder leans against a wall. The distance from the top of the ladder to the ground is 1 metre more than the distance from the foot of the ladder to the wall. So that's been put onto the diagram. So the distance from the ladder to the wall is, we're going to call that x metres. And because the height of this is 1 metre more, we're just going to call that x plus 1 metres. So the first part of this question is to use Pythagoras to show that x squared plus x minus 12 is equal to 0. So you've been given a little hint here that we're using Pythagoras. So if we remember our Pythagoras theorem, your basic theorem was that c squared is equal to a squared plus b squared. C squared being your longer side and then A and B being your two shorter sides. So if we were being asked to use Pythagoras, we would set up the basic Pythagoras and then we would substitute in the values from our diagram. So our long side is 5, so 5 squared. And then our short sides, we have x plus 1 squared plus x squared. So all we need to do here is break the bracket out, tidy up these terms, and we are looking to get as a final answer x squared plus x minus 12 equals 0. So 5 squared is 25. X plus 1 all squared, what we can do is we can write that out twice first of all, just to help us see it. And then we have the plus x squared. So that gives us 25 equals, and if we break these double brackets out with FOIL, we've got x squared plus x plus 1 plus the x squared at the end. And now we can tidy this up. So 25 equals, we've got 2x squareds, we've got 2x terms, and we've got a 1. So at this point, I'm going to write this the other way around. So 25x squared plus 2x plus 1 equals 25. And then I need to get everything over to the left-hand side because I want equals 0 on the right-hand side. So 2x squared plus 2x. I've got plus 1. 25 on the right-hand side, we would take away 25 from both sides to get that to be 0. So 1 minus 25 leaves you with minus 24 equals 0. Now the last piece here would be to factorise this through. So they all divide by 2. So 2x squared plus x minus 12 equals 0. And then if I divide both sides by 2, I get x squared plus x minus 12 equals 0, because 0 divided by 2 is still 0. That is now matching up to what I was asked for, so I can just write as required. For part B of this question, we are being asked to use this quadratic that we've just found here to find the distance from the foot of the ladder to the wall and the top of the ladder to the ground. So we're basically being asked to find x so that we can find these two distances. So for part B, we need to solve this quadratic to find our value for x. So we're being asked to solve for x. So x squared plus x minus 12 equals 0. So let's see if it will factorise into double brackets. We're looking for the numbers that multiply to minus 12, add up to plus 1 in the middle. So for minus 12, we could have 1 and minus 12, minus 1 and 12, 2 minus 6, minus 2 and 6, and 3 and minus 4 are minus 3 and 4. So the numbers that are going to give us that plus 1 in the middle would be minus 3 and plus 4. So if we pop these into our brackets, so minus 3 and plus 4, our two solutions, we've got x minus 3 equals 0, so x will be equal to 3. And we've got x plus 4 equals 0, so x would be equal to minus 4. Now, like I said in the last video, we're going to think about if our answers make sense. So we've got 3 and we've got minus 4. We can see here that straight away, using that bottom horizontal length of x meters, we cannot use the minus 4. That cannot be minus 4 meters long. So immediately we can just disregard this answer and we'll write beside it disregard, meaning that we're going to use the x equals 3. Now, part I of the question asked us to find the distance from the foot of the ladder to the wall. So that's that horizontal side at the bottom. So that's 3 meters. And then part 2 asked us to find the distance from the top of the ladder down to the ground. So that's the x plus 1 meters. So that will just be 3 plus 1, so 4 meters. Okay. So the questions I would like you to try today are just a few questions here from page 7, question 1, question 2 and question 4. So as I always say, mark your work from the back of the booklet and please come on to the Teams page and ask me if you need any help, and please email me your work whenever you get it completed so that I can just see how we're getting on. Okay, thanks guys, and I'll speak to you soon. Bye.